to tie all of this counting stuff together, I want to keep using this set of class data that I've already presented. So we had a group of 27 students, 20 who are first year, 7 who are returning students to the university, and an instructor is picking out 4 of them to put together for a group project of some sort. So the thing I want to consider to sort of guide us into the punchline here is, what if our instructors for some reason wanting a balanced split, an even division of the students. So we've got some more experienced students mixed in with the first year, sort of to show them the ropes. So that's a little bit trickier of a question, because now it's no longer a case of, well, how do we, like, what part of our group of students are we interested in? Do we just want the first years? Do we just want the returning students? No, we want them both, but we don't want all of them, making up the group or something like that. We need to look at this as kind of 2 separate divisions. So that's where we're headed once I clear some space. All right, so we've kind of got 2 separate things we need to do here. We need to pick out our first year students, and then we need to pick out our returning students, right? Right. So as far as the first years go, well, we've already said we have 20 of them. Of those, how many do we want? We wanted 2, because again, it's an even split. So 2. And then just like with our previous examples, the students aren't going to care whether their name gets called first or second. Are they in the group is what it comes down to. Order doesn't matter. As such, we're counting combinations. So we have 20 C2. All right. For the returning students, same deal. There were 7 of them. We're picking out 2. Order doesn't matter. So 7 C2 right there. And I sort of arranged things this way on purpose. So technically, yeah, you can work out these numbers. That's fine. You can get them. That's great. So this one works out to be 190. 7C2 should work out to be 21. So you get those numbers. That's awesome. What the heck do I do with them? How do I put them together? Well, I wrote it this way on purpose because if you think back, this is exactly how I was phrasing stuff when we were using the counting principle, right? So yeah, that's exactly what's happening here. We're making 2 choices. We're picking our first year students, we're picking our returning students. And these formulas have given us a way to count how many different ways each decision can be made. 190 and 21. So if we use the counting principle, those are written too far apart for my taste. You can see where they come from. But writing a multiplication dot with numbers separated by like 5 inches of space on each side is still really weird to me. So we have 190 times 21 according to the counting principle. And if I did my arithmetic right earlier, I would certainly hope I did, I get 3,990 different ways that we could have picked out our students in this case. So, I mean, you could play around with various, rearrangements of this. What if you only wanted one first-year student, sort of like one returning student as like a mentor to the first years, or something like that? You can play around with these options. So, sort of the key idea here is, yeah, these formulas can end up getting used as part of one of those fundamental counting principle, calculations that we've seen previously. So that unlocks a lot of potential for us in terms of trying to figure out the number of different ways we can count things. So I've got one more example that kind of ends up bringing this all home. So bear with me for a moment. What? Board games? It's kind of a jagged transition from talking about class group projects, right? So I've told you before, I like playing games. I talked about video game consoles earlier. So my family and I also like to play a lot of tabletop board games. So I've got one of our favorites sitting right here. So this game is called Legendary. It's a board game. You can see some important copyrighted characters are sitting all over the front of it. So here's hoping nothing weird happens. I didn't make up this game. This is published by Upper Deck. So just as a word of warning. So like I said, it's a fun little deck building game. You assemble a team of superheroes to punch bad guys. Which who doesn't like punching bad guys? Well, don't know. You get the idea. So, I really like games like Legendary. The catch is, I always like bringing it up in this format. So, most of my students, when I say, what would you expect to pay for a new board game, like off the shelf? I'll usually get back a number like somewhere along the lines of like $10 to $20 or something like that. So for what it's worth, if you're looking to buy a copy of Legendary, if you are, I've got a great local game store I can recommend to you in Asheville. But in terms of purchasing it, yeah, you're going to need more money than that. If I remember right, Legendary, its recommended retail price is either $50 or $60. So that's often kind of a moment for people because they're used to thinking about having bought like a copy of Clue, for maybe $14.99 or something like that. And so hearing that a board game costs that much money is kind of a there's a shock factor. I'm not going to lie. Now, as it turns out, I kind of like to play up the, sort of the advantages of a game like Legendary that's a little more expensive by talking about what board game aficionados will refer to as replay value. In some sense, the game doesn't keep playing out the same way. So, for what it's worth, yeah, there's some randomness built into stuff like a clue board or how Monopoly starts out. It's kind of deterministic. And like apart from where your dice rolls end up putting you on the board, I mean the flow of the game is going to be pretty similar each time. Legendary doesn't quite feature that. It's actually got a whole lot that goes into just getting a game set up for folks. So we're going to take a look at that setup here. So this is actually laid out carefully in the PowerPoint slide. So if you want to follow along in there, go ahead and do so. So when you're getting a game of Legendary together, so each game features, I think the game calls it a mastermind. I just refer to it as a boss. Somebody like Magneto or Doctor Doom. Somebody who's got something. They're in charge of all the other villains. And if you've ever read any superhero comics or watched superhero movies or anything of that sort, the bad guy always has some kind of scheme in play. So you got to pick as you say, so you choose one of the possible schemes. I won't get into what they are in the context of the Marvel superheroes, but whatever. All right. So once you've picked out the boss and the scheme, you'll have sort of specific like named groups of villains who work with him. So like sort of the other superheroes with the fancy special powers that show up. I can't spell. So technically, this is what they call, as you said, there's also what they call henchmen. They're just like robots or something like that. Because I can't seem to spell, I'm going to call them mooks because it's fun to say. Anyway, so now all of this is just setting up the bad guys, and all of these cards, a lot of these cards are basically getting shuffled together into one big deck. So then your superheroes, they end up in another deck. All right. So here's the the core structure of how we're going to set this up, and then I'll tell you how we can count each of these guys out. So for what it's worth, in the base game, I believe there are expansions, but I don't own them. So there are 4 possible mastermind boss villains, and of those, you pick out one. There's only room for one mastermind here. In terms of schemes, there are 8 of those in the basic box, and again, for any given game, there's only one scheme in play, which is good. Some of them are kind of painful to deal with. All right. So now moving on, we got our boss, we got our scheme. In terms of the villains, there are 7 possible factions of villains in the box, and of those, we got to pick out 2. So 7C2. The order's not going to matter. These guys all get shuffled together the same. The henchmen, the mooks. There are 4 groups of them, and again, we pick out 2. All right. So now we've done all of the bad guy stuff. Let's talk about the good guys. All right, so the base legendary box has 15 superheroes available in it, and of those we pick out 5. So theoretically you could just pick your 5 favorites, or I usually like actually pick 5 at random just to because I like making weird random teams of superheroes that may not end up together most of the time. All right, so that's our setup. We've got a bunch of this stuff running through here, and as we've said before, this looks like a fundamental counting principle problem. Once we get all these numbers, we can just kind of plow our way across. So as it turns out, 4C1, if you had just said, well, why don't you just say there's 4 ways to pick the boss? Yeah, that's what happens if you do 4C1. So we have 4 coming from that guy. From the scheme, 8C1 is 8. All right. So 7C2, if you think back, this actually came up in the context of that last problem. Right? So we have 7C2. Works out to be 21. 4C2 is in fact 6. So these numbers aren't really all that big at this point, right? So you might be thinking in terms of replay. Okay, great. This is a part of where a real big part of where this ends up flowing into this. So if you're picking out 5 of those 15 superheroes, when I worked out the combination count for it, I got 3,003. Okay. So now the counting principle says we multiply all of these guys together. If you need to hit pause while you type all this in, I totally get it. So when I worked this out, I got 12,108,096. So I was very careful, like, because it pops up in the calculator without the commas. So yeah. And this is just ways the game's set up. Never mind the whole I'm shuffling cards, and then there's going to be like draws and stuff that go into this. So yeah, there's a lot of different ways. I've played quite a lot of Legendary at this point, and I haven't really seen any 2 games that play out the same way. So there's a lot of flexibility built into this. So I'm not encouraging you to like run out and spend your money on Legendary. It's a good game, I think, but so that hopefully gives you some context for how we can combine that fundamental counting principle with some more of these more advanced counting techniques. All right, so that's chapter 2. Congratulations, you just unlocked a trophy. So we'll be moving forward, but I guess I actually mean moving backward, because once we finish up chapter 2 and we've done our test and everything on it, then we're going to talk about chapter 1, and you'll see why next time.